This video is going to help you get ready to go over the very last thing we did in Chapter 5, which was the day that we called quadratic modeling. We were solving quadratic inequalities, which is what you're looking at in front of you, and then we were also looking at modeling, given certain information, writing the equation of the parabola. So this is kind of the final piece of the chapter that you need to review. So this first couple problems you're looking at, your directions, and even on your test, are going to be very similar to this. It's going to ask you to solve the quadratic inequality. We talked about doing it with a graph. We talked about doing it algebraically. I'm going to walk you through right now what my expectation is when you do a problem like this, what I'm looking for on the test. First thing you want to do with these is you want to get them in a standard form and see if you can factor them. So we have x squared plus 2x minus 15 is greater than or equal to 0. We need to figure out when this equation actually equals 0. So that's why we factor. We're going to find those x-intercepts is what we're finding. So we're going to factor it's x and x. It's plus and minus. You get plus 5 minus 3. So what that tells me is your x-intercepts are at negative 5 and 3. We also refer to these as critical values. Critical values because they are the most important pieces of information about this parabola to help us solve it. So if you picture your quadratic, and you're welcome to graph it on your calculator, you can graph it on a piece of paper, you can just kind of think in your head, what is this going to look like? Well, my parabola is going to cross the x-axis at negative 5. It's going to cross the x-axis at 3. I know that this parabola opens up because my leading coefficient is positive. So I know that it looks something like this. Now, I'm not being very specific at all. I am really just getting a general shape. I didn't even take the time to find the vertex. The vertex in this particular problem is not important. What's important is that I understand that when I look at my parabola, it goes from above the x-axis to below the x-axis to above the x-axis. In class, we made a number line. We put the critical values on our number line, and we used a positive to represent when it was above the axis, a negative to represent when it was below, and a positive to represent when it was above. Keep in mind, it has to have this alternating pattern. Your parabola is never going to be positive, positive, negative. It's going to either go above, below, above, or it could be in reverse. It could be below, above, below. Now you want to look at what it was asking. It wanted to know when this parabola is bigger than or equal to 0. It's bigger than 0 or equal to 0 when we have positive values, the ends of this number line. So we want to write our answer as that part's the number line. You can think of it, you can even draw a little ray on your number line and say it's going from here to here, and it's going from here this way. Thinking of it more from earlier in the course. The way you write your answers, there's a couple ways, is you can say it's when x is less than or equal to negative 5 or greater than or equal to 3. That was that or inequality when you have the opposite ends of the graph going two directions. We also mentioned in class that there's a notation, it's called interval notation, which says that we're going to go from negative infinity, which means all the way to the left, up until we get to negative 5, and we're going to include that. And then we're going to join it. We use the capital U to say mean union or to join with from 3. So starting at 3 and then going all the way to the right in the positive infinity direction. I do not care on a test which way you write it. I know that this notation, this inequality notation, is more common for students, and so you're welcome to write it that way. But I want to mention the other way because we are going to get more into that later in the course, so it's helpful to start getting used to that notation. Second one, I'm going to do the same thing. It's already in standard form, so I don't need to move anything. I am going to immediately try to factor. It factors 2x and x. This is going to be a positive 4 and a negative 1. You can do a quick check. Make sure that it does FOIL correctly to give you that right middle term. That means my zeros or my critical values or my solutions are 1/2. That's what makes this 0. And negative 4. So again, if you want to graph it on your calculator and get that visual so you can see it, or if you just want to create your number line, as long as you have the factor and the critical values, that is perfectly fine. This parabola also opens up because it has a positive leading coefficient, which means it goes from above the x-axis to below the x-axis to above the x-axis, meaning it goes from a positive y to a negative y back to a positive y. The difference with this problem is it wants to know when is it less than 0. So when is it negative? It's negative in the middle. I am not including negative 4, so I'm actually going to put open circles there if I want to draw it. So my answer are all of the values between negative 4 and 1/2. The way I write that is from negative 4 is less than x is less than 1/2. I could also write an interval notation saying I'm going from -4 to a half. You'll notice I'm using parentheses because that means I am not including those values. Brackets include the values, parentheses do not. And these problems are done. So the biggest thing here, look at a picture, get that visual, see if you can factor it. They should be things that factor very nicely. It may take a couple tries and checking combinations. And then look at what you're trying to find. Are you trying to find when it's bigger than 0, so you're looking for when it's positive or above the x-axis? Or are you trying to find when it's less than 0, which means when is it negative or below the x-axis? The last skill that we had in the chapter was kind of going in reverse from the beginning of the chapter. In the beginning, you're given an equation, you have to graph it. In this case, you're actually given a picture or in this piece of information, and you have to come up with the equation. So I'm going to do one of each type that we did in class. We did vertex form and we did intercept form. So we're going to start with vertex form. Let me write the generic vertex form on the board for you so you can see it. This was the form of vertex form. What I'm going to give you is I'm actually going to give you the vertex. So I'm going to give you, we call it the h and the k value. I'm going to give you numbers to plug in there. What that means is, in my parentheses, if my vertex has an x value of -3, my parentheses is going to be x plus 3, because it's always the opposite sign. If the vertex has a 5 for the y value, then I'm going to put a plus 5 here. So that's the first piece. Now, I still don't know what a is. I'm not sure what a is, and the way I find it is I have to be given an extra piece of information. That's what this point is there for. That tells me if I replace my x with a 1 and a y with a -3, I can solve for a. So I'm going to put -3 in for y. I'm going to put 1 in for x. Most common mistake students make is not following order of operations. So make sure you follow parentheses first. So you're going to add 1 plus 3. That gives you 4. Then you have to square. You have to do exponents next. So 4 squared is 16. So you have -3 equals 16a plus 5. You cannot add the 16a and the 5 together because the 16 goes with the a and the 5 does not. Solve for a by subtracting 5. So you get -8 equals 16a. Divide by 16. You get a to be -1/2. And a is a constant. It does not have to be a whole number. It could be positive or negative. It could be a whole number or a fraction. So my final answer is y equals -1/2 x plus 3 squared plus 5. Great way to check your work. If you graph that equation in your calculator in your y1, make sure that it actually has the vertex that it's supposed to, -3, 5, and make sure it also looks like it goes through the point 1, -3. You could even use the value or the trace button to make sure when you put 1 in for x, you get -3 for y. Last problem is working this time in intercept form. So let's write the generic intercept form. Intercept form was made up of 2 parentheses. Another name for it is factored form, because that's exactly what it is. It's something that's already been factored. We're going to take the intercepts, so I'm telling you that the intercepts are -2 and +7, and fill in my parentheses. So that means if -2 is an intercept, that I have x plus 2. It means that if 7 is an intercept, I have x minus 7. Again, the piece of information that I'm missing is I have to figure out what a is, and that's why I have this extra point. There always has to be that one additional piece of information to help you finish it. So that tells me that if I put 9 in for x and 4 in for y, I can figure out what a is. So I'm going to put 4 here. I'm going to put a 9 in 2 places. I have to put it in this x and in this x. So I have 9 plus 2, which is 11, and I have 9 minus 7, which is 2. So 11 times 2 is 22, so I have 22a equals 4. Solve for a, I'm going to divide by 22. Again, I get a fraction, I don't get a whole number. I am going to reduce it. 4 22nds is the same as 2 11ths. So there is my a value. Final answer is just putting everything back together. So my final answer is writing my equation, y equals 2 11ths, x plus 2, x minus 7. And again, a great way to check your work, especially when you have that calculator sitting on your desk. Graph the equation, y equals 2 11ths, x plus 2, x minus 7, and make sure it has the correct intercepts. Make sure it really does go through the x-axis at -2 and at 7, and make sure it also contains the point 94. So it gives you a way for all of these modeling problems to check your work and see if your answer makes sense.